Hello students, in the last video we had studied about recursion. What is recursion and how the recursion works behind the screen in computer system, isn't it? Yes, let us take those points in mind and go forward in solving much more complex problems. Recursion, we know that it is a function, it is a different way of repeating the process by using function call, isn't it? Yes, when you take one simple function void x, yes, the recursive function, how it should be? It can be any number of commands within a function, and there should be one function called x of, and that function call must be written within the condition. Must be written within the condition. Isn't it? So such a way we have studied. So this is how, if you arrange the command within a function, what happens? The commands of function gets repeated again and again. This way, if you repeat the commands of function again and again, that is said to be as recursion or recursive function. Okay. In recursive function, we should remember two things. What is that? The every function works separately. Every function works separately. Function works separately. It means it maintains its own variables, its own data, its own code, all separately away from the main program, away from the normal work. It is almost like if I am giving any work to you as your homework, how you used to take the work to home separately away from the school. Yes, same way computer does the process separately. If the function, of course, recursive process is nothing but calling the function again and again. If you imagine that the function is called 3 times, yes, that 3 works happens separately. 3 works happen separately. It is first word, second word, and third word. It happens separately. There won't be any link. There won't be any relation between this block and this block and this block. So that 3 different blocks work separately. However, the codes are same, isn't it? The codes are same, but it works separately. Okay, working separately. Like if I am giving homework to 3 children, so how they do work? Yes, each one goes, however the work is same, but each one goes to different home and thus their work. Same way function works separately, recursive function, even if it is going to be called 3 times. And the second point, what is that? Since the function doesn't share value between each block, the one and only way to take the value from one function into another function by through parameters. Parameters, isn't it? Parameters are very important. Parameters. So parameter plays important role in function. Important role in function. So with the help of parameters, we can bring any new value into function. I can bring 1. I can bring any number of value into function. Whatever values are needed, that all value we can bring into function. And from here I can take another Okay, by through parameters we can take value. That's the thing we have studied in the last video, isn't it? How we can take value from one work area into another work area, isn't it? Suppose I want to take the value, count the value 1, 2, 3, like this. I want to bring here 1, here 2, in here 3. What should be done? Yes, we have to use parameters. int a. So first time I will be calling the function x of 1. Isn't it? So 1 will get passed into first area. 1 will get passed into first area. And here I want 2. Second time I want 2. What should be done? So a equal to a plus 1. And here you can write x of a. Now what will happen? So 1 comes here, and before reaching here, it gets incremented by 1. So 1 plus 1, it will become 2. That 2 will be passed here. So we are getting 2 here. And when it comes here, before reaching this point, it gets incremented by 1 because codes are same, isn't it? Codes are same. Only value is different. So 2 plus 1, 3. 3 comes here. So that 3 value will be passed. That's why you have written x of a. It will be passed. So x of a. So in here 3 plus 1, 4. So how we can stop exactly at this particular point? Yes, we can stop at this particular point by making use of the condition. So you have to call as long as a is less than or equal to 3. Isn't it? So when it comes here 4, it will not be called. It will not be proceeded further. So it will not go. So as long as 2 it will go, 3 it will go, but when it 4, it will not go. So such a way we have to set the counting. So set the condition accordingly. So this all we can do. How? When? Yes, you can do when you are going to remember these points. When you remember these points and the diagram of working, if you remember these two things, then we can frame the code very easily. Okay. I had given the practice questions for you. I hope so you all might have done, isn't it? So anyhow, let me take one example, isn't it? What is that example? Printing 100 even numbers. Printing 100 even numbers. How we can make program for that? How it should be looked into? Printing 100 even numbers. Printing 100 even numbers using recursive. So how we can do? Yes, we have to plan. So it means 100 times you have to print the number, isn't it? 100 times you have to print the number. It means we are going to make one function, we are going to make one recursive function. In that we will arrange the codes. That code is going to get repeated 100 number of times, isn't it? So we are going to arrange one code void yes even. We are going to arrange one code. That code is going to be repeated 100 number of times. If condition. Recursive function cannot be written in first attempt. Understanding without planning, we cannot write recursive function. So we have to repeat some. We don't what code is going to be, but some code, that code is repeated 100 number of times. So 100 times. So let us take first time, second time, third time, dot dot dot, 100th time. So like you say, you have to arrange the boxes. So what that box indicates? Box indicates that the function is going to get repeated each cycle separately in different places. So first time will be working here, second time will be working here, third time will be working here, and 100th time will be working there. That is the meaning. First time, what is the even number we want? So even number we want 0. Second time we want 2. Third time we want 4. So first time I want 0. First time I want 0. Second time I want 2. Third time I want 4. So fourth time I want 6. Fourth time I want 6. Isn't it? Fourth time I want 6. Like this is. So yes. So what should be done? Yes. So the next block value is based on previous block value. Isn't it? The next block value is based on previous block value. Isn't it? Yes. So what is the relation with the previous block value? Formula is if you add 2 you will get. If you add 2 you will get. If you add 2 you will get. Isn't it? Yes. So the first value what I am going to bring is 0. Isn't it? 0. 0 I will bring, and the second value, the second block I will take the value 2, and third block I will take the value 4, and fourth block I will take the value 6. Isn't it? Like this you will take. So this is how you have to understand. So first time even from main program I will send 0. So in here it is integer a, isn't it? So 0 will be received. 0 will be received in a equal to 0. So what I am going to do? I have to print the system dot out of println of a. That number I have to print, and I have to from 0 I have to generate next number. A is equal to a plus 2. A equal to a plus 2. Now it will become 2. That 2 I will be arranging here. A. So it means next time 2 will be positive. 2 will go. So 0 will be printed here, and 2 will be printed here, and 4 will be printed here, and 6 will be printed here, and so on like that. Okay, so I hope you are clear with that. And what is the last value? Last block value. Last block value. So today if it goes, what is the last block value? 100th value. 100th value for it should be 100th even number. 100th even number. This is first even number, second even number, third even number, fourth even number. Isn't it? So from the even number we will be able to find out how many times what, whether it is third even number or second even number or fourth even number, we will be able to find out from the number. 0 is first even number, 2 is second even number, 4 is third even number, 6 is fourth even number. Is there any relation? Yes, there is a relation. So, what is the relation? We can say that 1 first number means 1 into 2 minus 2. Isn't it? That is the relation. 1 into 2 minus 2. So 2 into 2 minus 2. This is the relation. Isn't it? Or from this we will be able to find out from 4. 4 divided by 2. 2 plus 1, 3. Third number. divided by 2, 3 plus 1, fourth number. Yes, we can find out. So from 2 divided by 2, isn't it? 2 by 2, it is 1 plus 1, 2. This is the second even number. 0. 0 divided by 2, it is 0 plus 1. This is the first even number. So this formula works. So it means from the even number, it is possible we can find out whether it is fourth number or fifth number, isn't it? Fourth number or fifth number or 10th number. What is the formula? And only we have worked out that. How 4 divided by 2, you will get 2, isn't it? You will get 2 plus 1. If you add, that is the one number indicates. So this is the third number 4. So that way we can find out. So even 100th, what is the formula? 100 is the number. So what is the formula? Same formula. What number you are getting, that one if you take n, or if you take that one as one number, even number e, divided by 2 plus 1, that will be definitely 100. That one definitely should be 100, isn't it? So if it is 100, that is our last block. So what you are going to do? E divided by 2. So what you are going to do? Yes, we are going to do condition. We are going to make 100th number. We should not proceed. We have to stop 100th number. So 0 we want 0 divided by 2. 2 divided by 2. Where 2 is coming? 2 is coming here. Afterwards it is incrementing by 2. So this A we should not take. This A we should not take. We have to take this A. Okay. This A is very important. How we can get that A? No problem. We can push this operation here. Instead of A, I can write A plus 2. Or I can write it here. I can write it here. A equal to A plus 2, semicolon A. Like this I can write. In here I can put condition A modular division, not modular division, A division by 2 plus 1 is less than 100. Is less than 100. Is less than 100. I hope so you are clear with this example. So, what example? Printing first 100 even number. I am not sure what is that. I was also not knowing. But with the diagram, I have worked out and brought these steps. Isn't it? These two steps I brought out. System dot order printing of E. What number we are passing, that number we are printing. Then what is that? We are generating next number A equal to A plus 2 and passing that value. So 0 plus 2, 2, passing the value. 2 plus 2, 4, passing the value. 4 plus 2, 6, passing the value. 6 plus 2, 8, and so on like that. And here exactly 100th block I have to stop. So how I can get 100? How I can come to know? This is 100th block. Yes, from the resultant answer we have tried to get 100 or to get the respective number. I want to get in here in first block. How I can get 0 by 2 plus 1. I am getting 1. In here this is second block. I want to get 2 from the result. 2 divided by 2 plus 1. In here I want 3. 4 divided by 2 plus 1. In here I want 4. 6 divided by 2 plus 1. So same formula, what number we are getting, what A we are getting, what value we are getting, even number we are getting, divided by 2 plus 1. That will be definitely 100th block. So that's the thing I have applied. A by 2 plus 1 is less than 100, then go. When it is equal to 100, we are stopping, not to go further. So this is how we can control. Or in another way also we can control. This program we can write it in another way also. How, if you have problem in finding difficulties, we can write it in another way. How I will, along with the even value, what is it? I will take one counter also. 1, 2, 3, 4. So I will take two values. One is the even number and another one is counter C. First time counter is 1, second time counter is 2, third time counter is 3, fourth time counter is 4, etc. So I will take two parameters. This is one method. I am going to talk about second method. In the second method, what is that? We are going to do the same work in a simple way. Because we are working here and there like that in a confusing manner. So simple way. How? Whenever we get even number, along with the even number we will do counting also. What even number it is. Whether it is first even number or second even number or third even number, like that counting also we will do beside along with the even number. That's the thing we are going to do. How? Void even integer a comma integer c. Integer a comma integer c. Integer a comma integer c. It means I will take two parameters a and c. First time a will be 0, c will be 1. 0 is the even number, 1 is the counter number. This is the first number, first even it will be known. So it means I will call this function even. I will call this function even with 0, 1. So 0 will be to a, 1 will be to c. Similarly, what is the next value of next box? What is the value? In here 2 should go and c also should go 2. In here next time, so a should be 4 and c should be 3. And next time, a should be 6 and c should be 4. And so on, like that it should be move on. So how we can do? So system dot out of a, isn't it? A equal to a plus 2, and we are calling even, isn't it? Even we are calling a comma c. Even we are calling a comma c. Close brace, open brace if condition. What is the condition? First time c is 1, second time c should be 2. The formula is c equal to c plus 1. That is the next formula. So a is even number and c is counter. So the counter. So first time we will have first block counter will have 1, second block counter will have value 2, and so on. 100th block counter will have the value 100, isn't it? So you have to do c is less than 100, isn't it? Less than 100. 100th block c will have 100, but c will have 100 here, but in here it will become 101, isn't it? So c is less than or we can do c is, so we want this c, so c equal to c plus 1, we can push within the condition, or we can adjust it here, okay, like this we can do. So this is another method of doing appending first 100 even numbers. I hope you are clear with how to write a recursive function for printing like a series type of values, isn't it? Series type of values. So similarly, we can make many process. Another example, what is that? Another fine example is want every digit 1, 8, 3, 2. Like this I want all digits separately through by recursive function. How it can be done? Through by recursive function we have to take out all digits of a number. We have to print all digits of a number. How it can be done? Yes, you might have done it through by for loop, isn't it? Through by for loop you might have done it. Suppose this is the number 2381. How we can take out one digit, last digit? Is the formula is n equal to n modular division 10. N equal to n modular division 10 if you apply, or 2381 if you apply, automatically you will get the remainder value 1. Remainder value 1. That is on last digit. Last digit. Isn't it? Whatever number it may be, suppose you get 2389. So 2389 modular division 10, you will get last digit 9. 9 you will get. So by this calculation, we can get last digit of a number. We can get last digit of a number, isn't it? So such a way we can get last digit of any number. And how we can remove the last digit from the number? Very simple. What you have to do? 2389 divided by 10. What will be the answer? 238.9. If you make integer data type, integer conversion, 0.9 will go. So it will be 238. So in here, what is the last digit is dropped. So this by this calculation we can remove last digit from the number. So if you know these two things, by repeating this process, these two things again and again, we can take out all digits of the number. First time you have to repeat, first time you have to do what was it, 2389, you will get last digit 9 and last digit will get removed. The next time you have to do the same work with 238, and you do 238, 8 will be the last digit and 23, 8 will be removed. And when you do repeat the same process with 23, 3 will be the last digit and 3 will be removed. When you do the same operation with 2 and 2 is the last digit and 2 divided by 10, so 0. When it is 0, we have to stop. Okay, such a way. So this is the logic of taking out every digit of a number. So in order to take out every digit of a number, we have to remember two formulas. Which is how we can take out last digit number modular division 10. To remove last digit, remove last digit n by 10. Isn't it? Remove integer of n by 10. Of course, if n is integer, 10 is integer, automatically result will be integer. So no need of this one. Isn't it? Such a way we can write n by 10. So this formula, if you repeat again and again, that is a new value of n. This is the removed digit, that is a new value of n. And if you do once again, yes, it is done. Next time you will get, and that digit will be removed, remaining digit will be set into n, then again it will go. So like I say, if you repeat the process again and again, we will get all digits of a number separately. How we can do this one? Through by recursive method. Yes, let's see how it can be done. Print digits, isn't it? Void digits. So I have to take one number, I have to receive one number, isn't it? So first time I have 4-digit number means I have to repeat the process 4 times. First time, second time, third time, and fourth time. If it is 5-digit number means we have to repeat the process 5 number of times, 5 block. If it is 6 digit number, means 6 times it is repeated. Isn't it? 6 block. So it means each block indicate the function should be called 6 number of times. So how many digits are there, that many times it is to be called. Isn't it? So first time, so in here what is needed? First time we want actual number 2389, and from that I will take out 9 and I will remove 9 and it will become 238. Then that 238 I will send here, and 8 I will take out and remove 8, it will become 23. That 23 I will send here, and I will take out 3 and remove 3, it will become 2, and that 2 I will send here, I will take out 2 and remove 2, it will become 0. I hope you are clear with what I am saying, isn't it? So suppose this is the number 2389. First I will send 2389. From there I will take out 9 last digits and remove last digit 9. So it will become 238. That 238 I will set it here. 238 I will remove last digit, and from there I will get 23. That 23 I will send. 23, 3 I will take out, 3 I will take out and remove, and it will become 2. That 2 I will send it. That 2 I will take out and remove, it will become 0. So this is the last block. So how we can arrange? So it means we will be calling the function digits of number 2389. I will send integer n. I will receive it in n. Isn't it? I will receive it in n. I will receive it in n. Yes, I will receive it in n. So first time I have read 2389. 2389. I am receiving it in n. Now from that I will take out last digit. To take out last digit, what is the formula? This is the one. So the last digit equal to n modulo is in 10. This is the formula to take out the last digit. And that last digit, what I have to do? What is the process? Printing. So we have to print system dot out dot print ln of d. Print ln of d. So it is printed. So 9 I am taking it out and printing it. It will be printed on screen. Then what should we do? We have to remove 9 from the number. We have to get 238. To remove, what is the process? This is the process. N equal to n by 10. It is removed. Now we have to afterwards that 238 you have to send it. So I will call the function digits of n. I will send, and I will add condition. We have to add condition to make the process limited, finite. So what is the condition? The condition we have to set. So this is the process. So we will first time 2389. It will be printed. Last digit we are taking out printing. Then remove last digit. It will become 238. Then we are crossing 238. From there, commands are same. Every block. So last digit it will take out 8 and it will remove. It will become 23 and we are sending it out. 23. Last digit we are removing. Taking out 3, printing and removing, it will become 2. 2 we are taking out last digit 2, printing and removing, it will become 0. So last block, what is the indication? The number will become 0. So that is the condition. We should keep generating blocks, keep calling process, go, keep going further, and at one block it will become 0, that time you have to stop. So if n is, what is it, greater than 0, then you have to go. When it is equal to 0, stop. When it is greater than 0, go. Equal to 0, stop. Come here. Close. It will be closed. Okay. So such a way we can